Alright, I'm going to run through one more composite function here. Let's say we've got f of x equals x squared plus 3, and g of x equals the square root of x minus 4. And let's say we want the f of g. Okay. Sometimes you'll see it expressed just like that, f circle g. I prefer this notation if you're going to use the circle notation, and even better than that, I prefer this functional notation that looks like that. Okay, and that's a composite function where you're going to squish two functions together. So the work looks just like this, f of. Now we replace g of x with what it's equal to. Alright, notice I just continue my work going down. So f of g of x is equal to this, which is equal to this expression, which is equal to, and now I go into function f up here, and it says take x and square it. Well, x in this case is what's inside the parentheses, root x minus 4. So I plug root x minus 4 into function f up here, and it says to square it. So I've squared what I plugged in, then add 3 to it. Here I've got the square root, or the square of something squared. They just essentially are inverse functions of each other, so it just becomes x minus 4 plus 3, and so x minus 1. And this follows all the way down. F circle g of x, read f of g of x is equivalent to x minus 1. So now, if we have a question that says, hey, what's the f of g of 5? I don't have to go to function g and find out what g of 5 is and then plug that into function f. Instead, I use this function that I just created. Since it is the f of g of x, to make it f of g of 5, I put a 5 in for x, and f of g of 5 is simply 4. And that's much easier to use that composite function than to run 5 through g and then take that answer and run it through f. Hope that helps.